Alrighty, so this class is on compressors and diagnosing them. And so basically there are two ways that compressors fail, which is electrically and mechanically. Yes. Bam. So we'll start with electrically, then we'll go mechanically at the end, because the mechanically is a little less involved. So electrically, compressors can fail in two ways, which is either shorted or open, just like anything else that electrically fails. Open being by far the less common. So on a compressor, which we all know, but I'll draw a really bad drawing just for kicks and giggles. On most compressors that we work on, there are 3 terminals with windings in between. And so when a compressor is shorted, which is the most common thing that happens, is the compressor is shorted to ground, what's happened is one of these windings is touching this imaginary casing internally. So the way you test that is you test for continuity from the actual windings to ground. Now in real practical terms, when you come up to a call where the compressor is shorted to ground, what usually will happen is that the breaker's tripped when you get there, you throw it on and it immediately trips back off. So at that point you would go outside and you would check to see if there is continuity from the windings to ground. Now where you don't test that is at the actual wires at the capacitor, or at the contactors or whatever. Unhook those and test, or worse, leave them hooked up and test. As much as you still shouldn't have continuity to ground, it's a really non-conclusive test. So the way you would test for continuity is to actually remove everything from the terminals at the compressor. Reasons being that eliminates any problems with the wires, that eliminates any problems with anything else. It eliminates sort of an oddity that I've seen is if the actual spades have melted and it's just melted to ground there. It eliminates anything else except the actual posts on the compressor. How you do not test for a short to ground is doing anything in between the windings. You're testing individually from each post to the actual casing. Practically, the casing is hard to test to because it's painted. You get bad connectivity to it. So you test to the actual copper. Scratch you a little clean spot, put it on there, and test it.
When you say test, you're talking about where do you put the dial on your meter?
You would put that on the continuity or ohm scale, depending on what meter you have. Some will have a ring out or ohms, but yeah, ohm scale.
And it's not supposed to...
And you should read infinite connectivity. You should read infinite resistance, that there's no connectivity in between them at all. Okay. A lot of times your meter won't actually pick that up. If it's not a dead short, it's not arced directly to it. For that, most people here have what's called a megometer. It can actually read through resistance, so it can read through the winding, through the insulation on the windings themselves, through the oil to the casing, and so it'll give you a reading of that resistance. Basically, a megometer is generating extremely high voltage, very low amperage current, and so it's testing to see if it can create a path through it. It almost always will create a path through it, but how much resistance there was to that path. So that is what you're checking for. You should have infinite resistance with your meter. If you have any connectivity at all, the compressor is shorted to ground. It's bad. There's not really any other way of checking that. I do always encourage, whenever you're done, do the redneck test on it, which is unhook the plug, set it in the bottom. If it has just there's spare copper, tape it up, whatever, set it there, reset the breaker, make sure everything else runs. If everything else comes on, the only thing that you've now changed is just that connection right to the compressor and nothing happens, you've effectively proved that the compressor was tripping the breaker. All of these tests are based on the breaker tripping immediately. It's not a hesitation where the compressor tries to run for a little bit and then trips off or anything like that. It's based on you reset the breaker and it trips off immediately. That's when you would assume that there is a direct short. Now, if you tested all of that and you get no continuity to ground, there is another kind of short that you can have, which is opposed to the compressor being shorted to ground, you can actually have a leg-to-leg short, meaning that coming into a residential air conditioner, there are 2 legs of power, and if those 2 windings in there have shorted together, you can actually have a leg-to-leg short. A lot of times on that, it won't just be the breaker for the air conditioner that's tripped, but the main to the house that's tripped. And so testing that, though, is a little bit more difficult, because if you hook your megometer to 2 of these windings and test, you're always going to read, it's always going to say that it's bad. And so at that point, you are actually testing post to post with your meter. It becomes a little more difficult because you can't say you should have infinite, but you should have some resistance between all windings. And so when you're testing that, if you read nothing, you read perfect continuity between it, you now have a leg-to-leg short. One of the ways, if you're saying maybe it's not a perfect short, but it's really, really low, one of the ways to test it, which, if you remember it, great. If not, it's not super important. Just do the redneck test. Is that when you're ohming out the legs of it, if you ohm out between common and start and common and run, and then add those two together, that will be, because the windings do almost look like that, where it's on either side of the common winding, and test between them, you'll get what these two added together. So if you add those two together, you'll have the resistance reading you should get between start and run. And so that, if those add up, you don't probably have a leg-to-leg short, although theoretically you could still have one that arcs, but then once it arcs and turns off, it's separating, or it arcs once it heats up, or something like that, which is where the redneck test is fairly conclusive. But those are the tests, and I know that sometimes we don't do the tests because we'll say things on a compressor where they just say, oh, the compressor's bad, or how is it bad? It's just bad. Which is fine. If you do the redneck test, you do know that the compressor is shorted and it's what's tripping the breaker and there's nothing else we can do. That's fine. But it's much more cohesive to say something like, it's shorted to ground, it has a leg-to-leg short. If you say that, you can say it accurately. And doing those tests does also prove that it's not just a mechanical problem, it's not just a locked compressor, it's not something else that's tripping it. Just maybe the weak breaker and the compressor's locked, so it's tripping very quickly. You've now proven that there is something wrong with that compressor in some other way other than the breaker tripping. Yes?
What are some common things that can occur that can be misdiagnosed as a shorted compressor?
That can be misdiagnosed as a shorted compressor?
Yes.
If you're testing it this way, there wouldn't be. But a lot of times it'll be misdiagnosed as a shorted compressor. A locked compressor can be, because it is just tripping the breaker. You unplug it, it stops tripping it. You say, oh, great, compressor. It can be that the wiring going to it is shorted. Like I said before, if it's actually melted somewhere at the terminals where that's creating a short, that can be diagnosed as it. So yeah, those are probably the common reasons for why. Now, the less common electrical problem that people will say, and it is probably the most incorrectly diagnosed thing on a compressor, is actually a winding being open, which is the compressor is not tripping the breaker, but the compressor just isn't running. You see this a lot where somebody goes up, compressor's not running, they check, have 240 volts to it, that's supposed to be applied voltage, it's not running, not making any noise, gotta be a bad compressor. So they'll pull it off. If they feel like testing any beyond that, they'll pull this off, they'll check continuity, they'll say, oh man, between common and start, I don't have any continuity. Nothing at all, open winding, done. Does anyone know why they would have no continuity there?
Overload. It's out on thermal overload.
Right, it's out on thermal overload. That is probably the singularly most misdiagnosed problem. The compressor's just overheated, it has a safety that drops out the common winding, which now leaves no continuity between the rest. And so it's not there. And so if you ever come up, compressor's not running, check to see if the compressor's hot at all. Even if it's warm, wait until it's totally cool before you ever diagnose an open winding. Open windings are a rarity, and so anytime you think you have an open winding, mistrust it a little bit. Yes?
What are some common causes of a compressor being out on internal overload?
Anything, pretty much anything that could make it hot. One of them that you can save yourself a little bit of time on is, if you go up and the compressor's overheated, hook up and check your charge. Compressors are cooled by the refrigerant flowing through them. If you hook up and your standing pressure on it, even though it's flaming hot, is 10 psi, you kind of know, hey, I probably should just start checking for a leak and not so much worry that the compressor's overheated. But yeah, anything that makes it hot. So the fan not running, just dirty condenser coil, excessively overcharged.
Anything that makes it way over.
Right, anything that makes it get hot. Right, so a bad capacitor will make it overheat. A weak capacitor can make it overheat where it has actually heated up the oil because it's overheated slower.
Okay.
Usually a bad capacitor will cause it to overheat, which is why it starts and turns off.
But if it heats up the oil too much, would it just destroy the compressor?
No, not really. I mean,
Oh.
you excessively did. I guess you could foul up the oil, but not usually.
The best one I found was a missized capacitor.
Right.
We
That
had a 45 microfarad capacitor and it was calling for a 30.
Right, that's a tough one to diagnose because the compressor runs. You cool it down, now it runs, everything seems fine. What you don't say is, oh, gee, guess it did it for no reason. Charge looks good, everything's fine. Probably just happened this one time. Anything that causes the compressor to work extra hard causes it to heat up quicker. And so on that, you would find that by amp draw. When it's running, you're taking it, oh, that amp draw is a little too high. Now finding that that is specifically the reason why the amp draw is too high is difficult. That's where it could be easily, you could look at it and just say, okay, well now there's actually a mechanical problem. It's not electrical, because I've tested that, it's running, winding's good, has a good capacitor, got to be a mechanical problem. And so that's sort of where it does start to transition from electrical to mechanical. Mechanical problems are anything that is mechanically wrong with the compressor. And so on something like that, an overamp, it becomes a little tough to decide between the two, because anything that's going wrong internally, so whether it's a slightly bent shaft, whether it's just the oil starting to slog on it or whatever, oil breakdown, can cause a high amp draw. So could that. And at that point, that's where there isn't, with mechanical problems, there isn't as much of a hardline diagnosis to something being wrong. There's more of, you're using your four senses, what does it sound like? What is my amp draw versus whatever? And so, really, as far as mechanical failures cause one of three problems. They either cause, which would be the same thing that's caused by a capacitor, they cause it to overheat or overamp, which, like I said, that would be a bent shaft or just, bearings going or whatever internally, causing it to overheat or permanently lock. And then the other problem would be is if the compressor isn't actually any longer compressing. And so you're having a low differential between the suction side or the input and output sides. You're creating a lower differential. And that is probably the hardest thing on a compressor to diagnose, is at what point do you know that it's the compressor, or at what point could it be, because what would your symptoms be on a compressor that's
running?
Right, that's running, but it's not
Well,
creating
your
good enough
suction
compression.
and your head pressure would all be almost the same.
Right, if they're almost the same, then it's fairly easy. But what if
We've
they're not
seen it
almost the
where-
same? If it's, your head pressure's 160 and your suction pressure's 90, it doesn't necessarily mean that it's only the compressor. It could be the TXV is under metering. It's just letting too much refrigerant through to the suction side, which would create low head, high suction. And so it becomes a little bit difficult to diagnose on that. But that is where you start to have to combine readings, where as much as, okay, this is a mechanical problem, but if the compressor is allowing refrigerant to bleed back through, it's not going to be working very hard. And so on that, how do you test how hard it's working? You check an amp draw on it. So you have low amp draw with high suction, where normally if it's just the TXV letting it too much through, high suction would naturally produce a slightly higher amp draw. But you have, half of your normal amp draw, well, then that's easy. You're now combining this third thing to prove that the compressor is slipping back. Another way that you can test that is the actual heat, meaning that the suction line, if the TXV or whatever metering device, if it's under metering, your line is going to have very near zero superheat. If the compressor is allowing hot gas to bypass right back into the suction, you're going to run a pretty warm suction line, particularly where it enters the compressor. You'll have an excessively hot suction line right there where it comes in. So that is where you're sort of trying to combine those readings a little bit, and there's not really any one reading that does it. Which pushes us to the last problem on yes?
What are some other things that can appear the same as a bypassing compressor?
Well, like we talked about, what could look like a bypassing compressor would be under metering of any kind, where it's just not, it's allowing too much refrigerant in. That the metering device is being used to create a differential. So if it's creating more differential, it is over metering. If it's creating too much differential, high to low side, it is over metering. If there's not enough, it would be under metering. But the hardest to diagnose problem that could look like a loss of compressor differential would be that the reversing valve is allowing discharge gas. The seals in that have gone, so it's allowing discharge gas to bypass right back into the suction line. And so on that, it is effectively doing the same thing as a compressor under metering, or a compressor having low differential. Really, the only way that I know of to test that is, Michael, would you like to say how you test that?
Temp change.
Correct. It is the temperature change in the suction line. Go. The common suction line, so from the reversing valve
But it's
to the
impossible
compressor.
to test. Like on a carrier, it's next to impossible.
Right, it's very hard to get the reading. But while it's running, which you can test with the fan off, although that makes it difficult, so you have to take it quickly. But if it's bypassing at the reversing valve, you're going to be taking that hot gas right to the constant suction. And so your constant suction, where it leaves the reversing valve to the compressor, will be hot. And not just sort of hot, very hot. And so if you test that, and it's, like I say, not just somewhat hot, but flaming hot right there, you can check it. If they actually have a discharge tap, which some units will have, you can check it there. And so if you check your discharge line and you have 300 psi, well, that's not what it's doing. Actually, I do have to backtrack a little bit, in that Mike had said overcharge can make it look like it. And it's actually somewhat of a good point, although I'm not sure if he meant it that way or not. But
That's exactly how I meant it.
but overcharge actually can, because compressors, or most modern compressors, have built into them a high pressure bypass. So if the compressor starts to get to above specs, it actually deliberately allows bypass. And so if you walk up to a unit with that, you'll hear it hissing and bypass. Now the way that you prove that that isn't it is fairly simple. Anytime you think a compressor has low differential, you turn it off, cool it down for a minute, open your reversing valve, make sure your pressure's high and low side equalize, then get your gauges on and turn it on. If it is just overcharged, you'll see the pressure go sky high at first, 300, 350 on an R22 system, 400, 450 on an R410A system. Then you'll hear it start to hiss and you'll see the pressures drop back to each other. If you see that happening, it is probably just overcharged. Or that the condenser fan isn't running, but I would hope you would have noticed that by that point. And so yeah, that's low compression loss. And then the last kind, which is really the only repairable mechanical condition, is if you have a locked compressor. Which a locked compressor, ideally, is a compressor that has really nothing wrong with it other than it's either set too long or it started to have some loss of oil, whatever, where it's actually just seized up, but there's nothing mechanically broken inside of it yet. It's just seized. You'll know that because it'll pull locked rotor amps when you go to start it, which will be listed somewhere on it. So if you start it up, you'll hear it kick off just like it would if it had a bad capacitor. You check the capacitor, it checks fine. If you put your amp clamp on the common leg, you'll get ridiculously high amps for the 3, 4 seconds, 2 seconds, whatever, until it overheats. And if you want to confirm that that is locked rotor amps, like I say, that'll be listed on the actual compressor. So you can see that it's locked. At that point, it shouldn't be locked unless it's cycled off. Make sure it doesn't have high head pressure on it, locking it. Occasionally that'll happen where it actually has something resisting it to start initially. But at that point, it's locked. And so you sort of have to see if you can unlock it. But at that point, we do need to always say, no matter what we say, the compressor has locked, which it should not do. Now they do, but they aren't designed to lock.
What are some potential reasons that a compressor would lock?
Really only 3 that I can think
It
of.
hasn't been used in a super duper long time.
Right. Most common would be if it's just hasn't run in a while. Second would be, like you said, if it had overheated. And so what's happened to that is that the oil has actually started to break down a little bit. And so now when it turns off, the components do actually start to seize a little bit, or they're a little bit off, or the internal seals on a reciprocating compressor are there. Or third would be what I had said before, where if it has, there's certain systems that when they cycle off will actually hold some head pressure. They don't equalize perfectly. And so the head pressure, the high side pressure, is naturally resisting that startup. And so when they start up, they just need a start assist to get everything flowing again to prevent them from locking up. And fourth, oil migration could cause it. Potential causes of oil migration would be if the condenser is just abnormally for whatever reason, higher than the air handler, oil migration can sometimes be a problem, which is a rarity, but it happens. If an accumulator doesn't actually have internally, they have like a dip tube that sort of feeds the oil back. If that has clogged, that can cause oil migration. Oil migration is a difficult thing to test. How do you test that the compressor is completely out of oil? You usually don't, other than that it's burnt through a lot of compressors. Yeah, so once you have determined that your compressor is locked, then you have to attempt to unlock it. Now it is important to remember that the compressor was locked, so no matter what you do, you always want to let someone know the compressor was locked, and whatever we're doing to fix it isn't restoring it to perfect condition and now everything will be great. There's things that you can do that do usually fix the problem, but you can't ever be like, oh, hey, now I've put in a hard start kit and everything's great. Which brings us to the primary way you unlock one, is you put what's called a hard start kit on it, which is just it's a start assist capacitor, so it applies, for lack of a better word, high voltage to it for a few seconds right at startup, just to start it turning, and then it has a relay that once it senses that it's run, it kicks it back off. It's either a time relay or actually senses current. And so a lot of times you'll put in, normally we'll say start with a small hard start. Start it up, see if it starts. If it doesn't, switch to a larger one. If it still doesn't, put both a small and a larger one. If it still doesn't, unhook the fan, and while it's starting, tap on it with a hammer while it goes to start, just to see if you can break it loose. Anytime you use a hard start to break something loose, allow it to run for a little bit, 15-20 minutes, turn it off, let everything equalize, then allow it to try to restart. First, I would say try to let it restart without anything if it's set for a while. If it's been running and they say all at once it stopped working, you're probably going to leave some form of hard start on it. But do make sure that it does seem to be able to cycle off and on now with the hard start. And hopefully everything's fine. Sometimes you will have one that's locked and you simply can't unlock it. And at that point it is just a locked compressor. Document every way that you tried to unlock it. And just go from there. A locked compressor, anytime you're recommending replacing a compressor due to a locked compressor, you do always want to explain that process to the homeowner, that the compressor's locked. Someone else may come along and try to do something more aggressive to break it loose and maybe be successful. I've tried everything that I know how, but a locked compressor isn't something where I can say I 100% know that no matter what anyone else comes to do, they can't fix this compressor. You can just say that I've done everything that I know how to unlock it, and certainly at this point, if I unlocked it, the odds that everything works great afterwards seem pretty low.